In today's weather, we do expect clear days for the... This just in, a multi-vehicle accident downtown. Police are on scene now. We have exclusive drone footage of the accidents. But I must warn you, viewer discretion is advised. Cut to the video. Well, it sure looks like both of them are gonna have a bad day today, and one of their insurance is gonna go through the roof. It's not clear exactly who's at fault in this situation, but Detective Bobby with the RCMP has enlisted the help of physics guy Jimmy. Now, to Detective Bobby for more information on scene.
We've witnessed a devastating collision here at Taylor Way and Marine Drive in West Vancouver. There are two parties involved, Miss J. LaRusso, who drove a truck, and Mr. C. Sandor, who drove the car. Mrs. J. LaRusso T-boned Mr. Sandor and knocked him into the intersection where they both drifted for a ways and then stopped. We've cleared the area, and thankfully there were no injuries, but we are starting an investigation because of conflicting claims made by both parties. Ms. LaRusso claims to have been braking before the collision occurred and claims that Mr. Sandor did not stop at the red light, whereas Mr. Sandor claims that he did stop before continuing and that Ms. LaRusso did not slow down. Because of these conflicting claims, we have made several measurements from the stoplight to the collision site, as well as to where they drifted to, as well as tire samples, masses of the vehicle, and the acceleration capabilities of the car. We sent this information to our physics department, where Jimmy will outline his findings. Thanks.
In order to find who is at fault, we must first start by finding the force of friction between the car and the road, as well as the truck and the road. First, we start by finding the coefficient of friction of the car using the known force of friction between the car tire and the road. Knowing this, we can solve for mu by using a quick division, which gives us 0.769. Solving for the coefficient of friction of the truck is now simple because we know that a truck tire has a coefficient of friction which is 70% that of a car's tire. 70% of 0.769 is 0.538. Now that we know the coefficient of friction, what happened immediately after the collision can be found. Looking at the car first, we know that it was sliding across the road immediately after impact. The only horizontal force acting on the car was friction, and because we know mass and the coefficient of friction, all of the components are in place to find acceleration. After calculations, the acceleration ends up at negative 7.5384 meters per second squared. The same steps are then repeated for finding the truck's acceleration, which is found to be negative 5.277 meters per second squared. Now we know displacement, final velocity, and acceleration for each vehicle. This allows us to solve for v0, which is the initial velocity from right after the collision. If you input the data from the car into the correct formula, you will get v0 to equal negative 11.12 meters per second, and for the truck, negative 10.77 meters per second. We now have all the information needed to find velocities before the crash. Now to find the velocities before the collision, you just need to remember that momentum is always conserved. The total north momentum as well as the west momentum will remain the same. Since before the collision only one vehicle moved north and one moved west, we know that all the northern momentum came from the car while the western momentum came from the truck. Since we have all the data, we just isolate the velocity of the car using the northern momentum after the crash and the truck using the western. The calculations leave you with the car's initial velocity of 12.783 meters per second while the truck at 12.509 meters per second.
Wow, thank you Detective Bobby from the RCMP and physics guy Jimmy. Well, folks, here's a lesson learned. You gotta be careful driving out on these streets. Have a good day.